In this video, I'll be showing you how to use 2 shift registers with the Arduino. And basically, we will be still using 3 pins as we always do with a shift register, but in this case, we'll be using 16 LEDs. And so usually we only use 8 LEDs on our LED strip, but now this time we can use 6 using another shift register. And so I'll be showing you how to do that in this video. So without further ado, let's get started. So here's this circuit here. We have 2 shift registers. So basically all we have is we have 3 pins right here connected to the Arduino, and it goes to the positive and negative, which we connect to the ground rails. So right here we connect it to the positive and negative side of the ground and positive rail to the power rails, and we also connect it to the other side, the breadboard as well. So these power rails also have positive and negative as well. Okay, so now we'll go ahead and look at how these shift registers are connected up. Now, if you want to know more about the shift register, I have a video also in the link below about the shift register. I don't show you how to use both of them. This is what this video is for, but I show more in detail about how to use the shift register. But ultimately, we just connect a power pin to positive 5 volts. We connect the output enabled to ground, and then we connect pin 10 to positive 5 volts as well. The same thing with this shift register as well. We connect these pins exactly the same, and then also the ground of each one of these chips will also be connected to the ground rail on the breadboard. All right, and so then what we have to do is now we just have to start connecting the pins up to the Arduino that need to be connected, which is the first pin here that we need to connect is the shift register clock, basically the clock pin as we call it, and this pin would be connected to pin 12 on the Arduino, as you can see. Then pin 11, it would be connected to the input pin on the shift register, also known as pin 14. And then we're going to connect pin 8 right here to the output register clock pin, which is also known as pin 11 on the shift register, will be connected to pin 8. And then we go ahead and set up all the LEDs right here, because all of these, including this pin right here, which is pin 15, this pin is the first output pin of the shift register. So this goes to the first LED, which is through a 330 ohm resistor. This resistor can be anywhere between 200 ohms up to 470 ohms. So basically we just connect it to that resistor, and then the other side of the resistor is connected to the other side of the LED, and then the other side of this LED will be connected to ground. And this is basically the same way that all these LEDs are connected up. They're just connected to different pins on the shift registers. Okay, and so this is like, for example, output 2. This would be connected to the next LED oval. See right here? This is for the next LED. And then output 3 will be connected to this LED, output 4, output 5, and so on. And then eventually, I think starting at this LED right here, then this LED, and then this shift register will control the rest of these LEDs right here. Okay, and so basically they are connected up exactly the same. We just have to pretend that we splitting this right here between this line right here. We are splitting these two strips apart. But now there are some connections we still have to do. We still have to connect this shift register up. We have this shift register connected to the Arduino, but this shift register is actually connected to this shift register. How we do this is we just connect pin 11 on the shift register to pin 11 on the other shift register. And then pin 12 will be just connected to pin 12 on the other shift register as well. So basically we connect these 2 pins together with both of the shift registers. Now it changes whenever we go to pin 14 right here, the input pin. This changes because this is where the actual bits are going, and of course these shift registers, both of them are going to be given different bits. And so basically where the bits are coming in in the first place when the Arduino sends them, it's coming from pin 11 on the Arduino. See right here, it connects to pin 14 on the shift register. But now what the shift register is going to do is, if there's any like remainder of what's left, it will go ahead and send the rest of the bits to this pin right here, and it will go ahead and send this to pin 14. Okay, so now this is the circuit, so go ahead and connect it up. I'm also going to connect it up as well, so that's what I'm going to do next. Okay, so now that we have finished connecting up our circuit, so now we can go ahead and look at the code that we need to upload to the Arduino. Basically, we just set up the pins right here. We have latch pin, pin 8, clock pin, pin 12, and then data pin, pin 11. and then we go ahead and go into the void setup, and we just set up all these pins that they're all going to be outputs. And so then we come into the void loop, and here we have a full loop, and we just basically define number to display, and it's going to be equal to 0. So right when we go into this full loop, this variable is going to be equal to 0, and then we're going to continue looping this full loop as long as number to display, this variable right here, is less than 65,536. As long as we're less than this, we will continue looping this for loop. But every single time we loop this for loop, this number to display variable will be incremented. So eventually we will come out of this for loop because eventually we will reach this threshold right here. Okay, and so basically this makes it so that we can slowly count up in integers. So basically the first thing we have to do is we have to do digital write latch pin low, getting ready to send the bits to the shift register. We have to do this to tell that information is coming, and then we go ahead and do shift out data pin clock pin. Basically we're just giving it these pins, and then we have most significant bit first. Basically this is just telling us which way the bits are going to be going in to the shift register. And so then we have a high byte and then number to display. So we just give it the number, and this will basically convert it into binary and then send it to the shift register. So we don't have to convert it into binary. We just go ahead and come down here and send information again. It's basically the same thing, but the only thing is different is low byte. So basically high byte is send high byte first, and basically this is second chip. This is the second shift register. So first we send the bits that are for the second shift register, because the Arduino can't send any more than 8 bytes. Okay, so it can only send information to one shift register at a time. It can't just do both at the same time. So it just sends one, which we say high byte. So when we use this function, the Arduino knows, okay, this is for the other shift register 2. And then after that, then we go ahead and send information to low byte, which right here is for the first chip. And then after that, after we sent the bytes for the second and the first shift register, then we will be done with displaying this number onto the LED display, and the new binary number should be displayed. So we will go ahead and do digital write latch pin high, saying that we're no longer sending more data, and then at this point the new binary number should be displayed. And we also wait 200 milliseconds. This is kind of fast, but we just want to see, you know, this is can be very large, a very large binary number, so it takes some time to actually for it to count all the way up to the top. So we actually have this delay quite small to make it so that it won't take that long. So basically that is the code, and so now we can go ahead and see our project in action. Okay, so now here's the binary counter. As you can see, it's counting up very quickly in binary. Now you may be able to recognize that this LED right here is not working, or it's not very bright, and that's just because the connection of the circuit that I have, it's not connected very well, so you're not able to really see it very well. But it still works like that. It still works properly, and so basically, as you can see, the LED strip has 16 LEDs that it's able to count with binary, and we are using two shift registers to do that. And so basically that is how you build this. And so if you like this video, guys, consider giving this video a like. Also comment down below if you have any questions, and consider subscribing if you want to see more content like this. Thank you everyone, have a great day. Bye.